Imagine a new storage system where you just go to Home Depot and buy a door. And that door is your portal to a fourth dimension. You open the door, put your boxes, close the door, you look on the other side of the door, there's nothing there. So this is what's going on when you have access to higher dimensions.
Wait, don't you have to then talk to somebody? Because as far as you know, if you're a scientist and you need data, what you have is something that you had, it's gone, and now a voice says, I've got this.
Yeah, if
that data?
If it's a voice from the fourth dimension, I'm going to listen to it.
So does every dimension
I'm not going to say, no, you're
not.
If there's a voice coming out of the fourth dimension and makes one of my boxes disappear, I'm thinking it's got more power than I do and more knowledge of the space-time continuum. So I'm going with it.
Does that mean that in order for scientists to credit another dimension with real existence, it will need a testifier from beyond? So you need a dimension plus a dimension voice? A
dimensionless voice. Yeah, that comes from another place. Now, there are things that happen in quantum physics that kind of defy our sensibilities. Like particles pop in and out of existence. They defy any rational attempt to understand it. Particles can be entangled with one another. A particle can be here, and there's a barrier, and it can spontaneously show up on the other side of the barrier at faster than the speed of light. All of this is just mysterious. Let me ask you. Suppose you have a sphere, and I live in a two-dimensional world, and you take this hollow sphere, so it's a shell, and you pass that sphere through my two-dimensional universe. How will I describe that? I will say, this point just appeared out of nowhere. Oops, now it's a circle, a small circle. And that circle's getting bigger by the moment. Oh my gosh, it reached a maximum size. Now that circle's just shrinking. It's shrinking. Oh, now it's a point. Now the whole thing disappeared. This would be completely freaky to a two-dimensional being. But it makes complete sense if you live in three dimensions and you pass a sphere through my universe. So, who is to say that some of the mysterious things we are describing accurately, but don't otherwise make sense in a higher dimension? And these are just the manifestations of higher dimensional phenomena in our world. And that's an aspect of what these higher dimensional physicists are trying to establish.
At this point...
Now I want to totally blow their minds, if I can, if I may. But you got to stay with me on this, okay? We're all Upper East Siders, so you got this. You ready? Okay.
These are not all Upper East Side. There are suspiciously un-Upper East Side people littering the room.
Okay. But you got to stay with me, okay? A point has no dimensions. There's no height, width, depth, so it has 0 dimensions. A line has 1 dimension, length. Okay? A square has 2 dimensions, sort of height and width. A cube has 3 dimensions, height, width, depth. We got this. Now follow me. A line is 1-dimensional, but it's bounded by 2 0-dimensional things. Those are the points. 1 dimension bounded by 2 0-dimensional points. A square is 2 dimensions bounded by 4 1-dimensional sides. A cube is 3 dimensions bounded by 6 2-dimensional sides. So in other words, the dimensions of your sides are going up. Your line is bound by 0-dimensional points. Your square is bound by 2-dimensional lines. I mean, by 1-dimensional sides. The cube is bound by two-dimensional squares. Okay? So we're going up 2, 4, 6. 2 points, 4 sides of a square, 6 sides of a cube. And each side is 1 dimension less. They're squares on the sides of a cube. They're lines on the side of a square. They're dots on the sides of a line. Let's go up to a 4-dimensional cube. A 4-dimensional cube has 8 sides. A regular cube had 6 sides. We're going up by 2. A 4-dimensional cube has 8 sides. And each of those sides is a 3-dimensional cube. 1 dimension down from itself. In the same way, each side of a 3-dimensional cube is a 2-dimensional square. So when you get to 4 dimensions, the sides are 3-dimensional surfaces. And you can take this all the way up. And our brains can't picture what we call a hypercube, in some circles a tesseract. We can't picture a volume bounded by 3-dimensional cubes. What does it even mean? This is because we evolved in the plains of Africa. Just not wanting to get eaten by a lion. Our neurosynapses are ill-equipped to do the distance on this. And this is why we invent mathematics that can take us there.
Well, the mathematics can help us imagine it, but if we want to credit it with reality, then you have to design an experiment that somehow touches your own world.
Yes, yes. So you can invent something that you can't see if it has testable consequences in ways that you can see. That's perfectly allowed. Not a problem. Mm-hmm. Oh, and by the way, there's some people that say you cannot prove a negative. Some people like coming after. Generally, you won't hear a scientist say that. Mm-hmm. It's others, like philosophers and people who like criticizing scientists, but who are not scientists. They'll say you can't prove a negative. We kind of do that all the time.